Hey guys, it's Lyret. In this video we will continue working on our AI for the lightsaber combat. My apologies for the audio volume. For some reason after Windows updates the microphone became like significantly less loud, and now I have to increase the mic volume manually, like 200 in OBS. So please drop me a note if I need to increase it even more in the next video. Hopefully through this one you will hear me more or less okay. Okay, so in the last video we did the thing where the guy actually saw us, and let's see if he follows, and he does follow us. Okay, so a couple of things we want to improve right off the bat is that we need to give him a bigger radius for the vision. And again, feel free to use pawn sensing and other means to detect a player. I'm showing you kind of the simplistic version of it. And, you know, it's one of the cheapest ones as far as I'm concerned. So let's put something like 7 meters there. Remember the unreal coordinates are in centimeters, so 700 centimeters is 7 meters. Okay, so the guy sees us and goes to us. He doesn't go immediately, so we can quickly check why is that. And you can see that this thing doesn't abort anything, right? So you remember how last time, as soon as we saw change, as soon as we saw target set in our custom decorator, we were aborting lower priority. Let's do the same here. So we abort the lower priority. Now he goes somewhere and he immediately sees us and goes to us. And the same happens here, of course. Okay, so let's add a couple of more minor blueprint nodes. Or yeah, maybe we don't edit them here in the blueprints, in a behavior tree, sorry, because this is more like more specific logic, which is not connected to AI thinking. It's more like a visual thing and combat readiness thing. So you can see that we're setting the target here and we're clearing the target here. It doesn't prevent us from doing more stuff here. For example, we can go ahead, we have a lightsaber, so let's do get lightsaber in the third person character bot, right? Get lightsaber, turn on. And let's do turn off as soon as we clear the target, right? Or maybe a couple of seconds afterwards, right? Let's do Retriggerable Delay, which basically means that if this still ticks, so for example I put here 2 seconds, 1 second passed, and then we do this again, this will update. So put here like 2 seconds. And of course, we can encounter a bug now, because if this is still ticking and then we turn it on, and then this ticks out, so this completes, and then we turn off, so this should be turn off, then we will have a bug there. So maybe, yeah, maybe let's keep ourselves from doing delays for now. Okay, boom. It turns on. You can see that we will get the ribbon all the time, and let's see if we can get away somehow. Well, actually, I know the way to get away from him, just like that. Okay, so he's trying to get to us. He can't really do that, so he turns his lightsaber off and just starts walking around. As soon as he sees us, he takes lightsaber and he goes towards us. Okay, so the ribbon is on all the time. We don't particularly like this. Let's check out what I can do about it. Okay, so we have the sprint in here. Let's not do that for now. So hold Alt to break and click to break the node. And let's go to the lightsaber. So Alt Shift O, lightsaber. Alright, so a lot of logic here, as you remember. Somewhere here there should be switch lightsaber ribbon. Once again, find references. This is it. Let's see who switches it on or off. I think it's in our third-person character class. So search for ribbon, and here they are. Sure enough. Okay, so it turns out that we switch it on here in the attack, and we switch it off after attack. So by default, it's supposed to be off. Oh, let's see what happens. So what this thing does is it takes the trail and deactivates it. So the trail, sure enough, has auto-activate. So as you can see, it's on by default. We don't want that. So this was a kind of a bug that we now found. So I turned off the auto-activate. That means that the particle is off by default. You have to activate it to turn it on. Let's see if it works for us. It does. And then it stops. And for him as well, he has a lightsaber. And it just works. Okay, so one other thing, of course, we don't like the color, so let's take care of the color. We have green one, let's give him red lightsaber, right? So, this is a lightsaber, and we don't have any way to change the color. So we can work with that. We have let's have a new function here, which is set color. We don't call it set lightsaber color because it's a lightsaber, right? So we call it on the lightsaber set color. And let's find out what kind of argument we need. What kind of color structure do we pass? So this trail, it has this element which is material, and it's a glow trail material, right? So if we open this material, it has color parameter, right? So for us, what we want to do is we want to have this trail with its custom material. So let's see if we can do this. Set material. Okay, so you can see that we can set material, and it will be the 0th material, but we want to create a dynamic material instance for this guy, right? So let's create dynamic material instance for the trail. So one thing you have to know, which is really handy, create a dynamic material instance. There's a way to create dynamic material instances, which are instances for which you can, in the runtime during the game play, you can change the parameters like scalar parameters, vector parameters, and texture parameters. It's really handy. So if you just do create material instance, it will just give you as a result the material instance dynamic, which is a dynamic material instance that you created in the runtime, right? Now you will need to set it here. So I would do this, right? Well, there is a shortcut for it, which is create dynamic material instance for particular component. In this case is trail. So if we create material instance for it, it will actually set it to trail. So we don't need to store it and set it to trail, because trail will already have it. Same goes for skeletal and static meshes. So we do that, and let's see what's the default one. Glow trail, right? Glow trail. Okay, so now what we need to do is we need to go ahead and set vector parameter, because color is vector parameter, and its color, the name of the color with its color, and you see the input is linear color structure, which is fine for us. Let's put color there. Okay, and of course the blade needs its own material as well. So we open it. Lightsaber glow is the same as, I think it goes to glow. Yeah, and glow has color as well. So slightly different materials, they're pretty much the same as far as I remember, because we did it together with you. So again, I can say create dynamic material instance for the blade, right? Because I have blade selected. And blade had lightsaber glow, right? So I do the same thing. I do lightsaber glow as a source material. And now for this guy, I can actually copy paste this set vector parameter value, because the name is the same color, and the same input color. So let's see if it works for us. this blueprint, yeah, right. Set vector parameter value for this material. Notice we're not saving them in the variables because they're already assigned to this blade and trail components. Okay, so let's quickly test it. In our third-person character, let's go to begin play, and let's get lightsaber, and then let's set color to something like blue, like sky blue, right? And you can see that's what we want, except for one thing, which is the light. As you remember, the light is a separate thing which we put there, so the light color is a problem. So let's go and fix it. So we have a point light, and the point light has light color. Well, just go ahead, point light, set color, set light color, and new light color is a linear color structure. So same thing, same exact thing. Save, compile. And you can see we get the desired effect. Great. So now the only thing left for us to do is to go ahead and remove this set color from third-person character, because we kind of, at least me personally, I like my green lightsaber, so I need to go to the bot, and bot has his own begin play. Now here's the important part. Let's again get lightsaber, and then set color, and set color will be red. So 1100, pure red. Let's keep it there for now. Let's see how it looks like. So one thing I want to mention is that, remember, if you have a parent class third-person character, if we open it quickly, you can see it has some begin play logic. Now blueprints simulate the same inheritance model and virtual functions as virtual functions kind of architecture or design choice as Java and C# and some other languages. So it means that if we go into third-person character bot, which is a child of third-person character, and we don't call the parent begin play when we implement begin play here, this will mean that we're not calling this guy because he's the parent. Parent begin play for bot is this guy. So it gives you flexibility, because at some point you can say, I don't want to call parent, I want to do my own thing. But here we want to do parent and then we do our own thing, right? Okay, so let's go ahead, look at our red lightsaber from this guy. You can see it's really red. Well, actually, it's pretty good. One thing is that red is not as bright as green. That's just how things work in nature. Maybe we just change it a little bit from pure red, because you can just make it brighter, or we can add a little bit, slightly green there, and it's much brighter now. But I think what we see in the movies is closer to this kind of color with the red lightsabers. Let's see. Yeah, this is again too much now, so let's decrease the blue even more. Oops, sorry. So yeah, now you start seeing the cool factor of having someone, fighting with someone with a lightsaber in the game on the level, because you can see as soon as he lights up the lightsaber, the environment lights up as well. So we start seeing these things. Now again, you can see one other issue, which is our oops, he put me against the wall. When he clashes his lightsaber against the wall, we get green particles. Again, you can have the same treatment to this problem as we had right now with materials, as I showed you. You would just have to change the particle color with materials, material instances, and so on and so forth. In the same fashion. I'm gonna just decrease this even more. And then, of course, one other thing is that, again, he has a red lightsaber, so he will probably need more glow to it. So you can add more glow if you go to, let's see. If we look at our glow material, we have a glow scalar parameter, and we have the color itself. So glow is set to 100. So only thing I need to do is I need to go ahead and in the set, oops, yeah, that's C++ code, sorry. We don't want to go there. Oh no, come on. Downable Visual Studio for me. Okay, so, yeah, please, yeah, go away. So in the set color you can also add one more parameter, which will be a glow. So you go to these materials. Let's only edit we only need to edit the blade color, right? So we have this thing, and we have set vector parameter value. We also have set scalar parameter value. Well, actually, wait. Yes, set scalar. Yeah, for the material. And glow has a parameter called glow, which is 100. So let's put this thing here as an input. Let's call it glow. And let's give it default value of 100. Because remember, for green it was set to 100 by default. So this will work here. If we put here glow. So again, we take the same dynamic material instance that we created. We set vector parameter for color, we set scalar for glow, and then we set light color for the point light. Okay, so now let's give it crazy test. Let's have like a lot of glow here. See if it works, and it does. It's just ridiculous. So I think I'll stick to like 200, so twice the multiplier there. Okay, now you can see that his lightsaber is glowing. Still not as much as mine, but it's a progress. Okay, so we've got that going for us, and the next video we will go towards the fighting and try to make our first attack. Thank you for watching, and see you next video. Bye bye.